Good morning students, welcome to your ICT classes. This is video number 26 on chapter 7, the laboratories in your computer. In our last class we have done activity 2 and activity 3, that is how does the nature of atoms change when they absorb heat and when the substances change their state. Today the learning objectives are to do some activities to learn how does the nature of atoms change when the state of the substance is changed, also when the temperature is changed. So we'll do some activities to learn the nature of atoms. So we'll open PHET software. For that, go to applications. From that, select school resources, PHET, then states of matter. Now select states. Okay, in your textbook page number 107, in Let's Evaluate section, there are 4 questions given. We'll do these activities in today's class. Our first question is, display the state of particles of water molecules at 120 degrees Celsius with the help of PHET software and save a screenshot of it. So, we have to select water as the substance and temperature is 120 degrees Celsius. Okay, now we'll select water. Then now the temperature is 146 Kelvin. We need degrees Celsius. So we have to change the unit of temperature. So click here and select degrees Celsius. This is minus 127 degrees Celsius. We have to increase the temperature to 120 degrees Celsius. For that we can increase the temperature from here. Click and drag the mouse upwards. When the required temperature is reached, that is when 120 degrees Celsius is reached, we can release the mouse. Okay, now this is 120 degrees Celsius temperature. Now what is the atomic structure of water at 120 degrees Celsius? The particles are moving. There is little distance between the particles. Attraction is there, but not that much attraction between the particles as in the case of solid state. So the particles are not that much closely packed or tightly packed as in the case of solid. The particles are moving apart. There is a large distance between the particles. Attraction is less, energy is more. So this is the case of water molecules at 120 degrees Celsius. So that was our first question. Now let's move on to our second question, that is display the solid state of oxygen with the help of PHET and save a screenshot of it. So we have to select oxygen as the substance and state we have to select solid. So we'll select oxygen, then select solid state. Now what about the atomic structure of oxygen at solid state? The atoms are very much closely or tightly packed. Attraction between the particles are very high. They are not moving apart. So the energy of the particles is very, very less. We can see the particles are that much closely packed in solid state. So that's about oxygen at solid state. This was our second question. Now let's move on to our third question, that is display the state of water and argon at 350 Kelvin and save a screenshot of it and compare these states. So we have to select both water and argon at 350 Kelvin. First we will select water, then temperature unit we have to change it to Kelvin. We need 350 Kelvin. So we can increase the temperature. Okay, so this is water at 350 Kelvin. What about the atomic structure of water at 350 Kelvin? Particles are close but not that much closely packed or tightly packed as in the case of solid. The particles are having little energy, so they are moving apart from each other, and there is little bit distance between the particles. They are moving, and attraction is there between the particles, but it is very less. Not that much in the case of solid state. So water at 350 Kelvin, the particles are not that much closely packed. but they are little bit closely packed, not that much as in the case of solid state. Particles are having energy, they are moving apart from each other, there is little distance between the particles. So that is the case of water at 350 Kelvin. Now let's see argon at 350 Kelvin. So we'll select the substance as argon. Now we have to increase the temperature to 350 Kelvin. Release the mouse when required temperature is reached. Okay, this is argon at 350 Kelvin. What about the atomic structure of argon at this temperature? Atoms are very loosely packed. They are not at all close to each other. The distance between the particles is very large and the atoms are having high energy and they are moving apart from each other. Okay, now let's compare water and argon at 350 Kelvin. In the case of water at 350 Kelvin, the atoms were some more close to each other. There was little attraction between the particles and the distance between the particles were there, but not very large distance as in the case of this argon. Okay, so for water at 350 Kelvin, the atoms were close to each other. There was little distance between the particles and the particles was having little energy and there was they were moving little apart from each other. But in the case of argon at 350 Kelvin, the atoms are very loosely packed, they are having high energy and they are moving far apart and distance between the particles is very much large. So that was our third question. Now let's move on to the fourth question. Observe the movements of particles in solid, liquid and gaseous states in PHET and prepare a note. Okay, now the substance is argon. We'll select solid state. What about the movement of the particles? They are not moving at all, because in solid state the particles are very much closely packed or tightly packed. They have no energy, so they are not moving apart. There is high attraction or very large attraction between the particles. So the particles are very tightly packed in solid state. There is no movement. Next, we'll select liquid state. In liquid state, the particles are having little energy, so they are moving apart. They are closely packed, but not that much closely or tightly packed as in the case of solid state. They are having some energy and they are moving. Distance between the particles is there. There is some distance between the particles. Okay, that and the particles are not that much closely packed. So this is the case of liquid state. Now we'll select gaseous state. In gaseous state, the particles are having high energy and they are moving very fast. There is no attraction between the particles. The particles are not closely packed. They are loosely packed and they are moving very fast. So movement of the particles in solid state, there is no movement. In liquid state, there is some movement because the particles have some energy, and in gaseous state the particles have high energy and they are moving very fast. Okay, now let's summarize what we have learned in today's class. We have done some activities to learn about the nature of atoms when they change their state, also when they change the temperature. So at solid state, the particles are very closely packed or tightly packed. There is no energy for the atoms, so they are not moving, and the attraction between the particles are very high, so there is no distance between the particles. They are very closely packed and they are not moving. And in liquid state, the particles have some energy, so there will be some movement. And the particles are not that much closely packed as in the case of solid state. And in the gaseous state, the particles have high energy and they move very fast. There is no attraction between the particles at all, and there will be large distance between the particles and the particles will be moving very fast. So that is the difference in the nature of atomic structure in three different states, that is solid, liquid and gas. Then about the temperature, when temperature increases, the particles gain energy and they will start moving. The attraction between the particles will get decreased and distance between the particles will get increased. And if the temperature is decreased, the particles will lose energy, they will come closer to each other, attraction will be more and distance between the particles will get lesser, and the particles will come closer and they will not move apart from each other. So these are the changes in nature of atoms when the state of the substance is changed and when the temperature is changed. So children, I hope all the topics that we have discussed today are clear to you. See you next class. Bye.